Today we're going to talk about volume. We've talked about surface area. A couple lessons ago we talked about surface area of prisms and cylinders. Today we're going to talk about the volume, the space that fills up the interior of the volume of the prisms and cylinders. So as we take a look at how to calculate volume, the volume of a prism and cylinder is similar because you take this area of the base and think about just stacking up that figure with similar shaped rectangles or similar shaped circles. So if we calculate the area of the base times the height, area of the base times the height, that gives us the volume of a prism and a cylinder. And in the case of a cylinder, it's pi r squared for the circle area times the height. Now, question for you, which stack of CDs is going to take up more space? The one on the left or the one on the right? You might say the one on the left, or maybe say the one on the right. Think about it though. It's the same number of CDs, and the CD cases are the same size, so they're going to take up equal amount of space no matter if they're stacked perfectly straight up and down or if they're not stacked so well. How about the stack of quarters? If it's the same number of quarters, which one takes up more space? You might think this one, since if we go left to right, there's a lot of space taken up there. But this stack takes up the same amount of space. We could calculate the volume of the stack of quarters if we knew the height and the area of the quarter. So that's kind of known as Cavaliere's principle. If the solid is straight up and down or whether it's slanted, if we calculate the height and the area of the base, it's going to give us the same volume. So since this figure has the same base and the same height, these would have the same volume. It's just a matter of this one is just tipped over. So now let's take a look at volumes of these different prisms. Let's say we've got a right trapezoidal prism. How are we going to calculate the area of that? Well, volume is area of base times height. Now the base in this is a trapezoid. So we have to calculate the area of that trapezoid. So there's multiple ways we can do that. So area of trapezoid times the height. And the height of the figure is the space between the two trapezoids. That'd be 5. So area of the trapezoid times 5. So trapezoids, there's a formula for that. Or break it into different pieces. So we've got a triangle here, triangle over here, and the rectangle in between. So we could calculate it that way. So we've got the triangles on either side, which if it's rectangle of 6 by 3, so 6 times 3, plus we've got two triangles which are base. If it's 14 total, that leaves us with 8 remaining for the two triangles. 8 times 3 divided by 2. And then we'll multiply that by 5. If you like to use the formula for the area of a trapezoid, that area is base 1 plus base 2 times height, and we divide that by 2. But you'll get the same thing as if we break it into different pieces. So as we take a look now, we've got 18 plus 8 times 3 is 24, divided by 2 is 12. So 18 plus 12 times 5, 18 and 12 is 30. And volume is equal to 30 times 5. 30 times 5 is 150. And our label is centimeters, but we're talking cubic centimeters. So 150 cubic centimeters. Why don't you pause the video and see if you can calculate the volume of the right cylinder on your own. Restart it when you're ready. So as we can see in this right cylinder, we've got a base shape of a circle times the height, so area of base times height. Be pi r squared times height, so pi times 9 squared times the height of 6 gives us 486 pi. feet cubed, or approximately 1,526.8 feet cubed. All right, I want you to try to see if you can figure out the volume of the right hexagonal prism. It's not a right cylinder. So let's see if you can figure out this volume. So volume is area of base times height. So the tricky part will be the area of the base. So area of the hexagon. And then the height, we should know already. The height between the two hexagons is 7. So see if you can figure out how to calculate the area of the hexagon. When you're ready for an explanation, restart the video. But I would suggest using this figure over here. This is 12 and 6 square root of 3. And keep in mind that these are all the same. It's a regular hexagon. Think about how you can calculate that area. So think about it for a while, restart it when you're ready. Okay, so if we break this hexagon into 6 triangles, I've got the base of the triangle and the height. So base times height divided by 2 and multiply it by 6, since I have 6 of them. So it'd give me 2 16 square roots of 3. And I plug that in for the area of the hexagon and multiply it by its height, because that hexagon goes up for 7 centimeters. So it's 1,512 times the square root of 3 centimeters cubed, or approximately 2,618.9 centimeters cubed. And we'll finish up by taking a look at the volume of these two oddly shaped figures. First one, we have an oblique prism, so it's not standing perfectly up and down. See if you can calculate that volume. Area of base times height. And number 5, we want to find the volume of the solid shown below. So we've got this triangular prism, but we've got a rectangular prism-shaped hole that we need to remove. So see if you can figure that one out as well. So pause that video again, restart it when you're ready to check. So remember, with an oblique prism, it's just tipped over. We still calculate it the same way. Take the area of the base. So in this triangle, base times height divided by 2, 9 times 5 divided by 2 times the height. If I were to push this thing back over, it'd still stand 8 meters tall. So we'd have a volume of 180 meters cubed. Next shape, we're taking this triangular prism and punching out a hole of the square prism. So I take the area of the triangular prism, subtract out the area of the square prism. I'm not given the height of this triangle. I know it's 10, it's an equilateral 10 by 10 by 10. So if I make an altitude, I know that I would have a 30, 60, 90 triangle. And if that's the case, this is 60 degrees, here's my 90, here's my 30. I know I've split this in half, 10, 5. I can use Pythagorean theorem or my knowledge of special right triangles to know that this is square root of 3 times bigger. So my height is 5 square root of 3 times the base of 10 divided by 2 times 6 gives me the triangular prism. And 3 by 3 is the base for my square times the height of 6. Simplify that all out, I get 150 times the square root of 3 minus 54, and approximately 205.8 feet cubed. So that wraps up our lesson on volume of prisms and cylinders. We'll get into cones and pyramids next time.